Alcohol, in the form of ethanol, takes a rapid journey through the human body, leaving its mark on various organs along the way. Upon consumption, alcohol enters the mouth and esophagus, moving quickly to the stomach. Only a small amount of alcohol is absorbed in the stomach. The majority of alcohol continues its journey into the small intestine. The small intestine is where alcohol absorption primarily occurs. Ethanol's small molecular size allows it to easily pass through the intestinal walls and enter the bloodstream. The rate of absorption can be influenced by various factors, including the presence of food in the stomach. Food slows down gastric emptying, which in turn slows down the rate at which alcohol enters the small intestine. Once in the bloodstream, alcohol is distributed throughout the body, affecting organs and tissues. It reaches the brain within minutes, where it exerts its intoxicating effects. The liver, however, is the primary site for alcohol metabolism, the process of breaking down ethanol into less harmful substances. The liver plays a critical role in detoxifying the body from alcohol. As alcohol circulates in the bloodstream, it reaches the liver, where it encounters a group of enzymes responsible for its breakdown. The primary enzyme involved is alcohol dehydrogenase, or ADH, which converts ethanol into acetaldehyde. Acetaldehyde is a toxic byproduct of alcohol metabolism, even more toxic than alcohol itself. It is responsible for many of the unpleasant hangover symptoms like headaches and nausea. Fortunately, the liver has another enzyme, aldehyde dehydrogenase, or ALDH, which quickly converts acetaldehyde into acetate. Acetate, unlike acetaldehyde, is relatively harmless. It is further broken down into carbon dioxide and water, which are easily eliminated from the body. The liver's efficiency in metabolizing alcohol is limited, processing roughly 1 standard drink per hour. Consuming alcohol faster than the liver can metabolize it leads to intoxication as alcohol builds up in the bloodstream. Alcohol's effects on the brain are complex, influencing a variety of neurotransmitters that regulate mood, behavior, and coordination. One of the main neurotransmitters affected by alcohol is GABA, or gamma-aminobutyric acid. GABA is an inhibitory neurotransmitter, meaning it reduces brain activity and promotes relaxation. Alcohol enhances the effects of GABA, leading to feelings of calmness and reduced anxiety. At higher doses, however, this GABA enhancement can become excessive, leading to impaired coordination, slurred speech, and slowed reaction time. Another neurotransmitter affected by alcohol is glutamate, an excitatory neurotransmitter that stimulates brain activity. Alcohol suppresses glutamate activity, further contributing to its sedative effects. This glutamate suppression, combined with GABA enhancement, leads to the overall depressant effect of alcohol on the central nervous system. Alcohol also affects the brain's reward pathway by influencing dopamine and endorphin levels. While alcohol generally produces similar effects on the brain and body, individual reactions to alcohol can vary significantly. Factors such as sex, genetics, drinking history, and underlying neurotransmitter levels play a role in how a person experiences alcohol's effects and the potential health risks involved. Women, for instance, tend to have higher blood alcohol concentrations than men after consuming the same amount of alcohol. This difference can be attributed to variations in body composition, enzyme activity, and hormonal fluctuations. Genetics also play a role, as individuals may inherit genes that influence alcohol metabolism, tolerance, and even the risk of developing alcohol use disorder. Drinking history also shapes a person's response to alcohol. Regular, heavy drinking can lead to tolerance, meaning the individual requires more alcohol to achieve the desired effects. This tolerance, however, can be misleading, as it does not equate to increased resilience to alcohol's long-term health risks. Prolonged and excessive alcohol consumption poses significant health risks, affecting nearly every organ in the body. The liver, bearing the brunt of alcohol metabolism, is particularly vulnerable. Chronic alcohol abuse can lead to fatty liver disease, alcoholic hepatitis, and cirrhosis, a severe and potentially fatal condition. Alcohol's impact extends beyond the liver, increasing the risk of various cancers, cardiovascular disease, pancreatitis, and neurological disorders. Furthermore, alcohol misuse can lead to mental health issues, worsen existing conditions, and contribute to accidents, injuries, and social problems. Understanding the science behind alcohol's effects on the body and brain empowers individuals to make informed decisions about their alcohol consumption. Moderation, personalized limits, and awareness of individual risk factors are crucial for promoting responsible drinking habits and minimizing alcohol-related harm.